Combustion. We all know that what is meant by combustion. Let us define that. We know that we will get a heat energy from the combustion. How do we get that? We will get that by the application of chemical reaction. This chemical reaction will be that means if a chemical reaction takes place, we are having certain chemical. That means if we are taken as a fuel, fuel have certain elements. For example, if we taken as hydrocarbons, these hydrocarbons will react with the oxygen that exhibits some of the heat energy. That means the reaction which take place is exothermic reaction. That means an exothermic reaction which exhibits the heat energy. This heat energy. For example, what we have meant, combustion which take place by the help of the chemical reaction. This chemical reaction, that means the certain elements which are like hydrocarbons or reacting with oxygen that liberate some of the heat energy. That means the reaction which take place in is exothermic reaction. By the help of this exothermic chemical reaction, we will get heat energy by the help of the combustion. Why we want to discuss about this combustion? Why it gives that much of importance? Because some of the parameters after combustion we get, that those are, first one is high temperature, and second one is high pressure. From the high temperature and high pressure, by using these two parameters, we can, for example, if you take a heat engine as an example, by the help of this high temperature and high pressure, we will get, by the help of this chemical reaction or by the help of the combustion, we get heat energy. This heat energy which will give the high temperature and high pressure parameters. By using these high temperature and high pressure parameters, we will drive the applications of this, like a heat engine. We can drive this heat engine by the help of these parameters. So that we can conclude this combustion is take place by the help of the chemical reaction. We will get by this chemical reaction we get a heat energy. By the help of this heat energy, by the help of the certain mechanisms, we can change this heat energy into useful work. We all know that the combustion process is take place in different this combustion process will be vary in different types of heat engines. It mainly depends on types of heat engines, because we know that two types, mainly we know two types: SI engine, and second one is compression ignition engines, and first one is spark ignition engine. In spark ignition engines, we are using homogeneous fuel mixture. In compression ignition engines, we are using heterogeneous fuel mixture. In spark ignition engines, we are using homogeneous fuel mixture. In compression ignition engines, we are using heterogeneous fuel mixture. That means due to these different types of fuel mixtures, we have different types of combustion process. That means the combustion is mainly different, depends on these fuel mixtures. We all know that what is homogeneous, what is heterogeneous means. If I taken as on fuel, a unit mass, a unit volume of fuel, I have taken any sample from this sample having similar composition when it is in homogeneous. But if taken as an heterogeneous mixture, we have taken any sample from this, we have very that means we will not get a similar composition. We will get a vary composition from every sample we have taken out from that fuel. So that this is the difference between the homogeneous and heterogeneous. We all know that how to get this homogeneous means, this is can be prepared in carburetor. That means outside of the cylinder. But the combustion is initially take place at inside, that means initiated at inside of the cylinder, but the homogeneous fuel mixture were prepared in carburetor and outside of the cylinder. Before going to further discussion more, we want to learn from more. We have to know the two parameters which are most important. Two features are more important in this combustion is the first one is ignition lag, and second one is ignition temperature. Ignition lag and ignition temperature. This ignition lag for this better understanding, I will tell an example and an application, then you get easily understandable. For this, take an incense stick and again matchstick. When we lighten up this matchstick, that gives fire. For example, if you think like that, if for case 1 kept this matchstick, fired matchstick, in below the incense stick, what happens? It will heat transfer take place. We'll take it quick. That means we'll kept in below this and taken out quickly. Then it cannot be burned. Second case we have to do, it will kept for some time and wait for it. After the incense stick is burned, then take it out. That means here what is it's a general example. Here what we are observed is what we give the time is an ignition lag. Why we want to give this ignition time? To get ignition temperature. Whenever the matchstick kept below the incense stick, the heat coming from this matchstick will enters into the incense stick, incense stick. That means when we increases the time which is kept below this incense stick, then the temperature is also be increases. What happens when we increase the time when kept below this, the temperature of the heat transfer that's transferred from these two incense stick will be increases. Then it's whenever it reaches the ignition temperature, then after it goes beyond this ignition temperature, what happens? The incense stick start burning. So that what is the ignition temperature means, the minimum temperature at which the ignition the combustion is take place or burns start. For getting this ignition temperature, we have to ignite that fuel. For it takes some time to be ignited. To get that ignition temperature is called ignition lag. Okay.